convert regular expression. Here directly regular expression is given. Convert regular expression 0, 1 closure plus 1 to finite automata. This is a direct problem. We know construction of automaton for a given regular expression according to Kleen's theorem, part 1. In second unit, during regular expressions, we solved many problems. So directly you can solve. First you can take given regular expression is 0, 1 closure plus 1. So this is in the form of R1 plus R2, union form. We know how to construct its automaton with epsilon default. The step 1, what you have to do, construct regular expression for 0, 1 whole closure first. Let P equal to 0, then Q equal to 1. Then regular expression is P 0, 1 whole closure equal to 0 means P, 1 means Q. So PQ closure. So we know how to draw its automaton with concatenation. First, draw NFA with epsilon for Q closure. That is for 1 closure. So for 1 closure, how to draw its automaton for 1 closure? So take one initial state and one final state. So first you can start with epsilon. Then here you can take the value of R, that is 1. Then again take one epsilon. The last one is the final state. For epsilon closure, so from initial to final state, one transition with epsilon moves. Then before final state, here you can see wherever the 1 is there in the reverse, from this to this, you can draw a transition with epsilon moves. Now you can see this is this figure denotes NFA with epsilon for 1 closure, regular expression. Now, but your regular expression is 0, 1 closure. Now you can concatenate with 0 with 1 closure. Therefore, NFA with epsilon for the regular expression 0, 1 closure is given below. You can combine these two. First, you can draw the 1 closure as it is. So now with epsilon, now there is 1 with epsilon here, from here to here 1 epsilon, from here to here 1 epsilon. So let us assume this is some Q, then P. PQ concatenation. So concatenation means again you have to take 1 epsilon between. Now you can start here. What is the value here? 0. Now see, let us see, this is what we assumed P. Now this is Q closure. P Q closure concatenation between P and Q. Again 1 epsilon. So now this figure is NFA with epsilon. Let us say figure 2. NFA with epsilon for 0, 1 closure regular expression. So before plus we constructed 0, 1 closure NFA with epsilon. Then again your final regular expression is 0, 1 closure plus 1. So you have 1 again. So then plus means you can take R1, R2, R1 union R2. So the final regular expression is 0, 1 closure plus 1. Let us say This is R. Now this is S. Then this is in the form of R plus S. Now we know R plus S how to draw its NFA. So for R plus S, the NFA with epsilon is given below. So here you can take R parallel paths. Here you can take S. Then take one initial state, one final state, connect with transition with epsilon MOOCS. So this is the R plus S. Now here what is R? You can substitute the R NFA, the above part. Then S you can substitute it as one value. So therefore the final NFA with epsilon for the regular expression. What is the regular expression? 0, 1 closure plus 1 is shown below figure. Now you can see. First you can take 0, 1 closure. So 0, 1 closure the NFA. So 0 with epsilon. Now the 1 closure. Here you can see. Now from here to here, one epsilon transition. Then here to here, one epsilon transition. Now you can see this is 0, 1 closure. Now parallel path, yes, you can take here. So here S means 1. Now here you can take one final state, union plus 1. You can add with epsilon transition. Now this is one more initial state you can take with epsilon, then with epsilon. Now this is initial state. Now this is the final NFA with epsilon MOOCS for the regular expression. If you can proceed the top path, 0, 1 closure you will get. If you can proceed bottom path, you will get 1. Now parallel path means plus. So this figure NFA with epsilon for the regular expression 0, 1 closure plus 1. Now you can name the circles starting with Q0 to Qn. Then this is NFA with epsilon. From this, if the question is construct DFA, NFA with epsilon to direct DFA, we have the procedure by eliminating epsilon MOOCS, direct method. Or NFA without epsilon MOOCS. For that also we have procedure. So like that you can find its equivalent automaton. So finite automaton means even you can stop here. The finite automaton with epsilon MOOCS this one. Sometimes they ask finite automaton without epsilon. Compulsory you have to remove epsilon MOOCS at that time. Now from this we have the procedures. First NFA with epsilon moves to NFA without epsilon MOOCS. We have this procedure. Second one, NFA with epsilon to direct DFA, subset method, set construction method. If the question is construct DFA, use this one. If the question is construct a finite automata without epsilon, use this one. Or simply finite automata, if the problem is complicated, larger problem, you can stop here itself. But wherever continuous epsilon moves are there in between states without loops, you can remove unnecessary epsilon moves. At that time, then you can so like that any given regular expression, we can construct its automata.